This is Tech Math 2, and we're going to do section 5-6. And in 5-6, we're going to add and subtract things. So if I have 1 and I add 2 to it, I should get 3 maybe. And if I take 1/2 and I add it to 1/2, I should get 1. And if I have 3/4 and I have 5/8, then I'm hosed because I can't do it. I have to find a common denominator. Okay, so my common denominator is 8. So I say that's 8/6 plus 5/8. 6/8, 5/8, and that's 11/8, and then everybody's happy again. Now, the fact of the matter is you're just going to put that in your calculator and switch it to a fraction, and it's going to tell you what it is anyway, so you don't really have to find that common denominator when you're dealing with those things. But your common denominator might be something else. I got a plus b, and I got a minus b. Now I need a common denominator. Okay, so what's my common denominator? Well, it's a plus b times a minus b. So I'd have to multiply top and bottom, a minus b, top and bottom, a plus b, a plus b. I can always multiply by 1. So this guy here and that guy there, they're just 1. Just another way to represent 1. So I got 2a minus 2b plus a plus b divided by a squared minus b squared. And then I can go and say, well, that's 3a minus b over a squared plus minus b squared, and then I'm done. So I still have to find the lowest common denominator. Lowest common denominator. Do I need the lowest common denominator? No, I could use any one at all, right? I could decide my lowest common denominator. I could instead of using my lowest common denominator as a plus b, a minus b, I could say, well, I'm gonna use a minus b squared and a plus b squared. I don't have to use the lowest one. I could use just something that gives me a common one. It's just that that'd be a bigger pain in the rear end than I need to have. So that's why I look for the lowest common denominator, so I don't have more work than I need. Okay. Questions about that? Too bad. All right, so we'll look at number 1. So I got 6x and I have an 8, and I want to find the lowest common denominator. Well, the 6 is 2 times 3 times x, and the 8 is 2 times 2 times 2 times nothing. And so I'm going to have 3 2's, and I'm going to have to have a 3, and I'm going to have to have an x to find my lowest common denominator. What's 8 times 3? 24? 24x is my lowest common denominator. So I factor out the things that I'm calling denominators in the makeup problem, and I find out what is common about them. I'm going to look at number 3 next. So I got 2k, 4k squared. So this guy's got 2 times k, and this guy's 2 times 2 times k times k. So my lowest common denominator is going to be 4k squared. Because I need 2 2's and I need 2 k's, and that's the way that would work. Oh, I'm supposed to do 3. Okay. We'll do 18 next. So I got t squared, t plus 3 cubed, t squared, t minus 3 cubed, squared, and t squared minus 9. Okay, so those are the things that I have. I think I wrote it down right. Okay, so the first guy, I've got a t, I got a t, I got a t plus 3, a t plus 3, and a t plus 3. And the second guy, I've got a t, and a t, and a t minus 3, and a t minus 3. And the last guy got a t, t plus 3 and a t minus 3 because I can factor that guy.
At first, it's actually t plus 3 squared.
Oh, well, you want me to solve the problem in the book? Oh, some people. I don't believe it. All right, well, I can, yeah, I'll lower myself and solve the problem in the book. Okay.
We appreciate it.
Yeah, you appreciate that one. Just because the author put it in the book doesn't mean that we should do it. Okay, anyway, so it looks like I need 2 t's. And it looks like I need t plus 3 squared, because I need 2 of them. So I need 2 of them, yeah. And I need 2 t minus 3's. T minus 3, t minus 3. And then we could rewrite that, right? Nothing wrong with that answer. Perfectly okay. Check. And, but we could say that's t squared minus 9 quantity squared. We could do that as well and say, okay, that's good enough too. Either way. All right. Number 20. Oh, I might be able to do that. Let's see, number 20. 9 over 20, if I could write a 20, minus 3 over 20. I already have a common denominator, so it's going to be over 20, and 9 minus 3 is 6, and then I say, well, I got a 2 up here and a 2 down there, so I can go 3 over 10 and call that my final answer. Now, there's no technical reason. I just can take my calculator. 9 divided by 20 minus 3 divided by 20 equals second function turned to a fraction. What says 3 over 10? No. So I could do that on my calculator perfectly okay. And I probably would if it wasn't so pathetically easy. When it's pathetically easy like that, I don't, let's see. We need one that's harder. I don't see anything hard on any of this pages so far. Okay, so 22 x over 3a 5x over 3. These are the problems that should be on the test, right? 6x over 3a. So the denominator stays the same. The numerator, which is the number guy in the top, we add those together. And we could do this. No, we're not going to do that. Well, we are. Okay, so we could have 1/2 plus 3/4, and we could recognize this 1/2 as half the pi, and this 3/4 as 3/4 of the pi, and then we could go and put that half of the pi with this half of the pi and get 1 and 1/4 left over. We could do that, right? Well, we did. What did you do? Is that in 6th grade? Yeah, probably did that. In 4th grade, you probably did that in 4th grade. Okay, so we're not going to do that. Okay. Looks like 26. It's the first time we have to do something other than pick our nose. 19 divided by 24 minus 31 divided by 60. So now I'm going to look for the least common denominator. So 24 is 2 times 2 times 2 times 3. And 60 is 2 times 2 times 3 times 5. All right. So now I see that my common denominator is going to be 1, 2, 3 2's. 1, 2, 3 2's, a 3, and a 5. Okay, so I'm going to multiply this guy 2 top and bottom, this guy by 15 top and bottom, and that looks too hard. Minus 62 divided by 120, and I got 120. 15 times 24, that can't be 120, is it? I don't need the 3. I only need a 10, right? I need a 2 and a 5. A 2. Oh, I don't need a 2. I don't need a 3. All I need is a 5. 5 over 5. That's better. So now I got 120 5 times 24, is that 120? Yes, it is. Okay, good. And then 5 times 19. Well, if that were 20, 5 times 20 would be 100, right? And it'd be 5 less than 100, so it'd be 95. Okay, so 33 over 120. And then I'd recognize I got 3 top and bottom that I can divide out. 11 divided by 40 as my final answer. Now, I really wouldn't do that, right? That would be my last choice of how to work the problem. First choice to work the problem would be take my calculator, 19 divided by 24 minus 31 divided by 60 equals second function change to a fraction, and I get 11/40ths, and I skip everything below there. That would be my first choice. Take my calculator and do it. Okay. Look at 27. Now, why would it be my first choice to use my calculator? No, I paid $20 for it. I want to get my money out of it, right? What are the chances of me getting it wrong doing it the other way?
A lot better than doing it wrong.
That's right. It's exactly. So the chances of me getting it wrong doing it the way, in fact, I did get it wrong until I figured out I got it wrong and I had to go back and change it. So yeah, so I do it on my calculator because I'm more interested in the correct answer than I am pleasing the math department on their ability to teach me to do math. Okay, so anyway, we got that down. X minus 1 over 12, 3x plus 5 over 20 minus x over 4. All right, well, now I need a common denominator. Okay, now I'm stuck. Can I do this on my calculator?
Yes.
Yeah, I think we can. I'm gonna get the right answer the long way first, and I'm gonna put it in my calculator and see if it's gonna work. Okay, so this is 2 times 2 times 3. This is 2 times 2 times 5, and this is 2 times 2. So we're going to have to multiply this guy by the 3 we're missing and the 5 we're missing, 15 over 15. And we're going to have to multiply this guy by the 3 we're missing, 3 over 3. And we're going to have to multiply this guy by the 5 we're missing, 5 over 5. All right, so I'm going to do that. 10x minus 5 plus 6x plus 15 minus 15x divided by 60 divided by 60. Okay, so 10, 16 minus 15 is x plus 10 over 60. All right, now I'm going to try to put it in my calculator. Okay, so I'm going to have parentheses 2 times x minus 1 close parentheses divided by 12 plus parentheses 3 times x plus 5 close parentheses divided by 20 minus x divided by 4. Enter. Stupid calculator. It gives me, calculator is giving me 4 over 15. Somehow, I have no idea how it did that. It must be assuming some value for x.
1 over 6.
Yeah, 1 over 60 is not 4 over 15, though. So, now, numerical solve. Numerical solve. We're going to use that guy next. No, that's going to have, that'll give me what x is equal to. No, can't use that. Well, we're hosed. I guess we have to do it that way. Unless you have a TI 85, 86, 89, 92 calculator, then those will just do it. That's not a problem. And I can put it in the Maple too and do it, but I'm not gonna. Okay, so that was 27. Okay. Now number 35 looks like it's something we already did, right? 1 over A plus 1 over B plus 1 over C. We've already done that one, right? That's resistors in parallel, basically. 1 over that, right? So we can just write down the answer. A, B, C, A, B plus B, C plus A, C. Right, so no problem. Because if this were 1 over 1 over, we would have said that that's ABC divided by AB plus BC plus AC, right? Because it's the resistor problem left over from circuit analysis. All right. So now you don't remember that. You don't recognize that as the resistor problem left over from circuit analysis. So you're going to have to come up with a common denominator, which is ABC. So the common denominator is ABC. In order to that, I'm going to have to multiply that guy by BC, this guy by AC, this guy by AB, and I end up getting the same answer anyway. But why take the circuit analysis class if you're not going to use it for something sometime, right? So it's really one of those things. All right. Moving down to 40. 4 over S minus 3 minus 1 over S. My least common denominator appears to be S times S minus 3. Okay, so I'm going to multiply this times S over S, this guy by S minus 3 over S minus 3, and we end up with S minus 3 on the bottom, and I have 4S minus an S giving me a 3S, and then I've got minus 3, and I see that I can factor that. I can factor that 3S minus 1 divided by S minus 3, but I'm done there. So why an S? Why is it that we are perfectly happy with X, Y, Z's, A's, and B's, and all of a sudden somebody throws in an S? Any idea? None, right? No idea at all? All right, so this is obviously a commie hippie plot. There's no other excuse, right? It has to be a commie hippie plot. So if we turn to, see if I can find the right page. Yeah, turn to page 1047. So on page 1047 of your textbook is the Laplace transform tables. Laplace transform tables. And what is sitting there in the? Oh, you don't go that high because you only have volume 1.
I have volume 1.
If you only have volume 1, then you're pretty hosed. All right. But that's why you need volume 2 later on. Anyway, if you look at the Laplace transform tables on page 1047, you'll see that you got S's all over the place. Yeah. Well, I could go, huh? What? Oh, you don't have that?
You don't have that one. 1,000?
Yeah, 1,000.
No.
I'm going to bring that out.
6,600.
Yeah, but that's because you didn't get volume 1 and volume 2. So there we go. There it is. And notice that you got a whole lot of S's. Well, you don't because that's the wrong page. You notice that that's the wrong page, so that's not the way you do it. But you got S's everywhere. S. So the S the author throws in chapter 5 is a prelude to using S's when you get to differential equations in chapter 30. So he's trying to get, and in fact, you end up solving this particular problem with the S in it you're doing here is one that you would do in Laplace transforms in chapter 30. So you're not only is he, but he's using it as just an example here, but it's something that you're going to use later on. So he's trying to take your mind and change it from the normal things, and so now S will be okay when I get to chapter 30 and S. Oh yeah, an S. Yeah, Laplace transforms, yeah, no problem. I've used S's before. I can make an S. Yeah, see how that works? Oh. So look at 47. Oh yeah, 47 looks cool. 8 over x minus 4 plus 2 over 4 minus x. All right, well, if these both said x minus 4, life would be so much easier, wouldn't it? So I'm going to multiply this guy by minus 1 over minus 1. And when I do so, both sides will say x minus 4, and now I have a common denominator. And now I've got 8 minus 2 is 6, and I'm all done. Now, I could have done that differently, right? I could have said, well, my common denominator is obviously 8 x minus 4, and then I'm going to multiply top and bottom by 4 minus x, and then plus 2 over 4 minus x times x minus 4 over x minus 4. All right, so I could do that. All right, and now that I've done that, I've got, what's that, 32. 32 minus 8 is 24. I got minus 8 minus 6x divided by x minus 4 minus x. So I could do that. And then I could factor out a 6, and I could have 6 times 4 minus x over x minus 4 minus x. Oh, look at that. I have things that are common that can cross out, and then I get the same answer I got the other way, but the other way is so much more elegant, right? Yeah, so I could have done it. I could have found a common denominator and ignored the issue of one just being minus the other guy, and done that as well. Okay, number 50. Our job as electronic technicians is, no matter what, find the path of least resistance and then secure it before I lose all my voltage. Divided by 3R minus 15. All right, well, looks like I'm relatively stuck here, doesn't it? All right, so it looks like I'm going to have to multiply top and bottom by 3R minus 15 on this side, 3R minus 15 on that side, and 5R minus 12, 5R minus 12. All right, so it looks like that's what I'm doing. So 3R minus 15, 5R minus 12. There's no reason to think that that's going to factor. Oh, wait a minute. I can factor a 3 out of this one, right? So this could be 3 times R minus 5. Okay, I can't factor anything out of the other guy, though. Okay, so I've got 36 R's. And then what the heck is 12 times 15? Anybody know? 12 times 15. Uh, 180 minus 180 minus 25R plus 60. Okay, that's probably what I got. What's that? 11R? 11R minus 120 divided by 3R minus 5, 5R minus 12. And I would have thought that I could have factored that the author would have made the problem better so that I could have factored in and got something out. So now the issue is, do I really have the right answer? Which one am I doing? I'm doing number 50. Okay, so what we're going to do is do the other thing I do when I'm in doubt of anything. I just come up on Maple, put it in Maple, and see what it says. And I know I don't want any hint. All right, so we got 12 divided by 5r minus 25. 5r minus 25, that wasn't the problem I was doing. 5r minus 25. Nate, where were you? You're supposed to tell me I was doing the wrong problem. 5 divided by 3r minus 15. And it just should simplify that for us and give us an answer. Oh, way to go. Way to go. Yes, that was really good. Simplify. The guy above me. There we go. 11 divided by 15 times r minus 5. That's not what I got. You do notice that that's not what I got, right? All right, so I didn't get that. All right, so, but we also notice that I'm not working the right problem. So if we change our color to red and change this to a 25, then change this to a 25 and that to a 25, and we can factor 3 out of there. That doesn't do anything for us. Change this to a 25, and okay, so everything's fine now. 3, 36, 100 and minus 118. 5 times 5 is 25r, and 5 times 25 is 125, and it would be a positive guy. All right, so that looks good. I still get 11r, but that guy is 55. Is that what he is? 55. Okay, I have a 25 sitting down there. Okay, so have I made enough corrections? All right, so I've got 11r minus 5 divided by 3, r minus 5, times 5, r minus 5. All right, so the r minus 5 goes away. I got 11 over 15 r minus 5. Is that what Maple said I was? Oh yeah, Maple. I like Maple. $128 is all it takes to buy a Maple. And it solves things that you would not believe. Anyway, claims to be the power of 1,000 mathematicians. Well, can you imagine 1,000 me in the same room? It'd be pretty tight in here, right? Yeah, couldn't turn around. That wouldn't be good. Okay, so that was 50. All right, let's yeah, I guess we'll drop down to 64. Number 64. All right, 2x, x squared minus 4, minus 2 plus x, 2 minus x minus 2, x plus 2. Okay, well I recognize this guy as x plus 2, x minus 2, right? So it'd be really cool if this guy was x minus 2. So we're going to make him positive, and we're going to turn him around to x minus 2. All right, and then we're going to multiply top and bottom by x plus 2 on that guy. and top and bottom by x minus 2 on this guy. And now I've managed to fill up my entire screen and not have enough room to work the problem. So that was rather professional. So I got 2x plus, what is this? This can't be 2 plus 4. That's 2 plus x. Okay, so 2 plus x, so that's x plus 2 squares. It'd be x squared plus 4x plus 4. And this guy's going to be minus x squared minus 4x plus 4 divided by x squared plus x squared minus 4. All right, that looks good. So now I've got an x squared and I've got a minus x squared. I got a 4 and I've got a minus 4. Okay, that worked out good. Now I've got 2x, I have 6x, I have 10x. 10x over x squared minus 4. Is everybody accounted for? Yes, it is. Should we go in Maple and see if Maple can do that? Yeah. No? Okay, Ben says that it's okay the way it is. Excellent. Turn the page. All right. 71 looks pathetically easy, so I'm not sure I want to do that one. But we'll do it anyway. 71. And we'll do it in Maple first so we know we have the right answer. So simplify. Simplify x squared plus x plus x. Bummer. Parenthesis. Oh, that was bad. Hit the wrong button. Alright, so I need parentheses, parentheses, divided by x cubed plus 1. X cubed plus 1. What is that? 1. 1. Seem to have a spare mark there. Okay, that's better. Thought I had a minus there. Plus 1. Plus 1. Close parentheses. Okay, so Maple says I'm going to get x squared plus 1 divided by x squared minus x minus 1. Okay, so that's what Maple says. All right, so let's see what we can get. I've got x times x plus 1 on the top, and I've got x plus 1 times x squared minus x plus 1 on the bottom, and then I've got plus 1. And so the one I want is the same as this. I'm going to go x plus 1, x squared minus x minus or plus 1 divided by x plus 1, x squared minus x plus 1. So I've changed the 1, so I have a common denominator. Okay, so that guy goes away, he goes away, this goes away, that goes away. Looks like I'm going to have x squared, the x's go away, I got an x and a minus x, plus 1 divided by x squared minus x plus 1, which as I recall, that's exactly what Maple told me it was going to be. So I thought I could make Maple bigger than that. There, that's better. Is that better? Can I do one more? No. Oh, yes, I can. Oh, yes. There we go. See it all the way. Ben can see it all the way in the back of the room now. All right. Doesn't even need his sunglasses on or anything. Okay, well, I guess we'll take attendance and call it a day. Thus ends section 5.6.